All right. So a Mahout is essentially a scalable machine learning library built on top of Hadoop and is written in Java. Okay. So it started with the Hadoop and now it is compatible with a lot of other similar systems and it even runs independent of Hadoop. Okay. It's essentially written based on an Angie's paper. There was a paper called MapReduce for machine learning on multi-core, and it started as the sub-project of Lucene, and afterwards it became the top-level project in of Apache in 2010, which is 4 years ago. Okay, and Mahat is a Hindi word which means it's a keeper or the driver of elephants, right? Yes, you are right, Naveen. So if you have exactly, so I forgot to mention that part. So in case you have two map reducers in which one finishes, then you make a copy of the output of the file and put it somewhere, and then you run another one. Or even if you don't copy, you just start with the whatever reduce produced. So all of those things are fairly possible. So in those cases, you will have two map reduces action when okay to go to the next action. All right. Okay of the first one will go to the next action. Now, all right. So what is machine learning? Machine learning is basically feeding a lot of data to computers and let computer figure out. So these are machine learning is a branch of computer science which deals with computer themselves learning a lot automatically based on our data. Okay. So we train it's a branch of AI, artificial intelligence, and it helps in design and development of algorithms. And based on the idea that computers should evolve the behavior based on empirical data. Okay. In the most simplistic case, if let's forget about all machine learning for a minute, the extrapolation of the data by plotting a graph and doing a future prediction based on that graph has been there since ages. Okay, it is just that machine learning takes that to a whole new level and gives you a very high precision results after understanding a lot of data, and it delivers the output at a very fast rate. Okay. Now, there are three kinds of machine learning. One is supervised learning. Okay. In supervised learning, we concretely label our training data. So all machine learning has a training data, and based on that training data, the algorithm learns and then starts imitating you. Okay. So first one is supervised learning, in which we concretely say or concretely label the data and feed it to the machine. We say, this is the spam, this is not the spam, this is the spam, this is not the spam, and so on. We feed all of this kind of inputs to the machine, and and after a while when you feed an email, it should be able to concretely say that this is the spam or not. Okay. To do that, we do a lot of things. We create a classifier, we define the classifier in terms of various words encountered and so on. So that is supervised learning. Second part is the unsupervised learning one. In unsupervised learning, okay, the data is fairly unlabeled. Okay, the data is fairly unlabeled, and we on this unlabeled data, we create a function that can predict the output. Okay, and I mean, basically, we give the classic example of unsupervised learning is given a lot of data, just classify it automatically into 5 buckets. Okay, so we haven't given any label or anything. We have just told that this is my input data. Just classify into 5 buckets. Okay, and we will think about the labels later on after we have the buckets. Third one is semi-supervised learning. Okay, we make we make use of unlabeled data for training, typically a small amount of labeled data with a large amount of unlabeled data. What does it mean? We have only very minor indications of labels, and using those labels, we try to figure out various kinds of detailing. Say, for example, we look at image. We look at an image and we try to predict whether it's a cat or a dog or whatever it is, and we have only minor hints, may be available, may not be available, such as the name of the file. Okay, say, I mean, that's I mean, name of the file may be available, may not be available, because on world wide web people might give a correct name or not. So that is semi supervised learning. So maybe 10 years ago, the machine learning did not have much of application. Specifically, why? First, machine learning required a lot of training data, which means millions of records or maybe hundreds of thousands of record. Only then it is of any use. Only when you have that kind of records, only then it gives you a decent amount of output. Okay, if you have 10 records, or if even if you have 1,000 records, you won't be getting any sensible output out of the machine learning. All right, so so these are the few examples of machine learning. So first one is recommend friends, date products to end user. This is like far more popular than any other. Second one is classify content into predefined groups, okay, such as your Gmail inbox. Third one is find similar content based on object properties, meaning you may also like this, or people who like this also like this. Identify key topics based on collection of text. What? Basically, what Google News does. Based on the collection of text, it figures out what is this news about and accordingly correlates with other news articles. Detect anomalies within given data. Okay, so when we know that genuine data looks like this, and this is the data which is coming in, it should be able to figure out that there is something wrong with this data. Okay, and that's used generally in firewalls and generally in other similar kind of applications. So computer vision, natural language processing, bioinformatics, speech and handwriting recognition, and search engine results, and I mean, there are various kinds of user feedback learnings also, where we see that this person is clicking on this record based on the recommendation. Okay, so these are the few applications of machine learning which are into a lot of into a lot of use right now. Okay, so when we talk about machine learning tools, because when you meet people, they anybody who is programming in even Excel might claim that they are machine learning experts. Okay, so if you have few lines of data, okay, if you have few lines of data for analysis and visualization, your whiteboard in office is good enough, or pen and paper is good enough. But if you have kilobytes to megabytes of data, okay, up to lower megabytes means 20 MB, MATLAB, Octave, or R is good enough. Okay, but in case your data is bigger than MBs and in low GBs means say 30 GB, 50 GB, and so on. And in those cases, NumPy, SciPy, these are the libraries provided by Python, and other libraries are good enough for analysis. And you might require Flare, mcharts, and Raffle to do the visualization for you. While if your data goes beyond gigabytes, up to terabytes or petabytes, you don't have a visualization tool. For visualization, you will have to represent this data into a smaller statistics. Only then you will be able to represent it. Second, for analysis, you would require something like Mahout or Giraffe or MLlib. This is MLlib, not MLib, MLlib. Okay, machine learning library from Apache Spark. So a recommendation example is this one simple example where there are reviews. Person A likes a particular movie and has given a particular rating. Now, based on this, can we give the recommendation to these people? Just based on this, we don't have any other attribute of these people. Neither we have the attribute of Sandeep and Kumar in this example, nor we have the details about these movies, like who are their directors, who when was the movie launched. We don't have those information. All we have is this. So can we generate the recommendation for these users just based on this? Okay, now let's just move to the next sessions before we. All right, so for this, first download this data. Okay, let's download this data. I have already downloaded it. For the example which we are talking about, we are trying to generate recommendation based on three columns: user, movie, and how much this user has voted for this movie. Basically, we are trying to generate the recommendation based on this. How is that possible, first of all? So you will have to figure out the similarity index between various users, and then you start cross selling. So movies liked by Sandeep may be useful to Kumar. And first we have to figure out of millions of users that these are the similar users. Eh, okay. So your life is actually simplified by Mahat, because for Mahat, if you are using any of the recommendation examples, all you need to do is prepare comma separated file with these three columns, and that's good enough. All you need to do is prepare a file with three columns, okay, containing some ID of the user, some ID of the product, and some ID of the rating given by this user. And it will give you the recommendation for all the users. I'll show you how. So first, if you want to download it, you can download this movie lens data. Movie lens contains the recommendation from the website called movie lens. Download it, unzip it, and then you start. First, you convert this data into. All right, so let me. I have already downloaded. Okay, so we have in my folder. I've already downloaded this. So this essentially contains my movies. Okay, these are all the movies, and then we have ratings. Okay, so not this one. This is already ready. Okay, so this is our movie ratings file. Okay, all right. Now we have got this ratings dot dat. We want to convert. We want to convert it into comma separated one. What will be the best approach? Anybody? And we want only first three columns. Okay, good, good. And we are only looking for the first three columns. That's all. Cut. Okay, good. SED cut. Excellent. Anybody else? Awk. Excellent. So basically we need to convert the ratings available to us, which we downloaded from Movie Lens database, is in this format, double colon separate. So first one is user ID, movie ID, ratings given by the user to this movie, and on what date. This is the date, the fourth one. Anybody? How do you convert this file to comma separated one? Other than Avdesh and Vishal? What we want is from this file, we want to convert it into this format. Okay, this format into this format. Yes, yes, regex. Okay. So can anybody mention the pig also? We can actually use pig in case this file is bigger. We can use the pig in the sense that run pig, load this file using pig loader and mention colon. So if we say pig and let me just run it locally. Pigx local, and I say my data equals to load ratings dot dat using pig loader. Could not resolve pig loader. It was pig catalog or pig loader. Oh, it was pig storage, right? I forgot completely. Okay, Now you can out of D. Now what you can do is you can project on a new data for each D and generate $1, $2, and $3. Not $1, $2, $3, $1, $3, and $5. Yep. But the big storage, that big storage only take a single character as the separator. Uh, all right. So try to do that. Okay. I'm just so right now I have all I did was I did this and generated my ratings.csv. Okay. All I did was did awk and generated my yeah. So Vishal is right. Instead of referring it 123, I'll have to refer 135 instead of that. I should have referred it $0, $2, $4, and that's all. And then using pig storage, when we say store my set into one particular file using pig storage, and then I mention comma, and that's all. And we'll get the rating.csv. There are multiple hundreds of ways. So once you have got rating.csv in this format, so where did it go? It is, where is it? Okay, ASCII, and I say 1 million, and we have got ratings.csv, right? Now in this, once we have done that, we'll have to copy it to our HDFS. Okay, and after that, once you're done with it, you can run, it's already there. I have already done it. Okay, it should be somewhere. Yeah, ratings.csv is there. So ratings.csv, after you have done that, you can execute the recommendations. Okay, now the output is going to be in recos and it'll take a lot of time to run. And at the end of it, what you need to understand is that at the end of the whole process, you will get, okay, you will get recos. Okay, so what is it saying? It says the output already index exists. And let me just delete this. What is the date today? 14th December. So yeah, so after you have run it, the output you will get is in one of the folders called, what does it say now? Once you have done, you will get the result in this format. So you didn't have to do anything. All you had to do is prepare your input in the format user ID, product ID, and rating. And in the end, you will get this. You'll get the recommendations. Okay. So you can also specify how many recommendation you want per user, maximum recommendation per user, and it will give you only that much. Or you can also define that up to what rating you want it to be displayed here. So this basically says for this user, this product is recommended and this much is the quality of the recommendation. Same is this and so on. Okay. You can take this file and put it on your web server where, or you can move this data after loading. This is basically, you can see it's a first one is one value and second one is it's a tab separated value, so it can easily be loaded using pig, and you can format it in whatever manner you want to format. Maybe you can use a pig storage of JSON and output it in JSON format so that your web application server can load it and serve it to the users. For this user it needs to display these recommendation, for this user it needs to display these recommendation, and it can do that. Okay, does it make sense to you? Now what is the problem with this guy? Okay, okay. This already created some sort of temporary data. All right, it'll take a lot of time to run. So there are other algorithms in Mahout which we can use, and they have their own use cases. You should look at the other examples of Mahout, where all other algorithms are mentioned. This is just for the recommender. What I want to emphasize on this particular command, where we have said that Mahout recommend item based. This particular example where we are recommending movies to the users is item based recommendation. And then we are telling that use this particular algorithm for movies. Okay. There are other algorithms, you should go through them, go through them and understand when to use which one. Okay. This is my input file, this is my output file. Sounds very simple. Internally, Mahout basically gives the data to all the nodes, and internally Mahout is actually calling Hadoop MapReduce, and scheduling its work. Right? Internally, that's what it is doing. So this time, what was the problem? All right. So let it run. Let it run, and it'll take maybe some time, some more time to do things. Alright, so using a simple command, you were able to generate recommendation of this form. Alright, and that you can basically also convert it into JSON or any other format, and In case you want to further customize Hadoop Mahout, in case you further customize Mahout, you can, instead of calling Mahout from command line, you can write your Java program and call Mahout's library as if it's a function. And in return, instead of giving you this rigid format of tab and this kind of a format, it will give you proper object format, okay, which you can present in whatever manner you want to do. All right. So that's pretty much for today.